Let's explore Newton's law of cooling by looking at how a hot cup of coffee cools down over time. We start with a freshly brewed cup of coffee at 95 degrees Celsius in a room where the ambient temperature is 20 degrees Celsius. Newton's law of cooling states that the rate of change of the temperature of an object is proportional to the difference between its own temperature and the ambient temperature. Mathematically, we write this as dt/dt equals negative k times T minus T room, where K is the cooling constant. Let's visualize this with a graph. On the vertical axis, we'll plot the temperature difference between the coffee and the room. Initially, this difference is 75 degrees. As time passes, the temperature difference decreases exponentially. The steepness of this curve at any point represents the rate of cooling. Notice that the curve is steepest at the beginning, when the temperature difference is largest. As the coffee approaches room temperature, the rate of cooling becomes slower and slower. Let's look at some specific points in time. Initially, when the temperature difference is 75 degrees, the cooling rate is about negative 37 degrees per minute. After 2 minutes, when the temperature difference has dropped to about 30 degrees, the cooling rate is only about negative 15 degrees per minute. And after 4 minutes, with a temperature difference of only about 12 degrees, the cooling rate has slowed to about negative 6 degrees per minute. This demonstrates a key principle of Newton's law of cooling. The rate of cooling is greatest when the temperature difference is largest and gradually decreases as the object approaches the ambient temperature. In practical terms, this means your coffee cools most quickly right after it's poured, and the cooling rate gradually slows down as it approaches room temperature. Remember, this same principle applies to any object cooling or warming to reach ambient temperature, not just coffee. It's a fundamental law of thermodynamics that helps us understand how heat transfer occurs in the real world.